Hello all, this is Trusha Patel. Welcome to the lecture of Intermediate Code Generation. Now as we know that language processor is having two phases inside, one is front end and other is back end. The source program will be given as an input to the front end. Front end will generate IR, that is intermediate representation, which will be given as an input to the back end, and back end is responsible to generate the target program. Now, in this lecture, we are going to talk related to IR, that is intermediate representation. Now, why we cannot convert directly from source program to target program? Why there is a need of IR? So this IR will be the machine independent code. Now, there are few advantages of using IR. First is we have a source language will give as input to the front end and it will generate the IR, which is basically the machine independent code. Now this same IR can be used for the multiple machines using the multiple backend, and each backend will generate the machine code, which is but obvious depends on the machine. So we required only one front end and multiple backend depends on the machine. So this will provide the reusability of the front end. Second advantage is we can apply the machine independent code optimization on this IR. Now we'll talk about intermediate languages. There are three flavors: syntax tree, postfix notation, and tree address code. Talking about first, that is syntax tree, which is the natural hierarchical structure of your source program. And if we represent the syntax tree in a compact form, then it is called a DAG. Now, postfix notation is the linearized representation of the syntax tree. Now, talking about the third, that is tree address code. Tree address code is a sequence of statement which will be of form x is equals to y operand z. Here x, y and z can be names, constants or these compiler generated temporaries, and OP can be any operand. Why it is called three address code is it can address maximum three addresses. So as we have seen, that is x, y, z, maximum three addresses we can use in this representation. For example, if we have a source language statement x plus y multiplied by z, the three address code will be generated such that t1 is equals to y multiplied by z. So y multiplied by z will be performed first and answer will be saved in the t1, that is temporary variable. Then t1 will be added to x. So x plus t1 and value will be assigned to t2. Now same way, if we have the syntax tree, we can also design the three address code for the same. So here if we have the first this unary operation, that is minus c, which is going to be saved in t1. So this is my t1. Now next this t1 is going to be multiplied with b, so that will be saved in my t2. So t2 is equals to b multiplied by t1. Next operation is unary c will be assigned to some t3. So t3 is equals to minus c. Then this t3 will be multiplied by b, that will be assigned to some t4. Now this t2 and t4 will be added. So that will t5 is equals to t2 plus t4. So this will become my t5, and t5 will be assigned to a. So here a is equals to t5. So likewise, three address code can be generated from the syntax tree. Now if I convert the syntax tree in a DAG, my 3 address code will be compact one. So you can see that the number of temporary used will be 3 now, which was 5 in case of the syntax tree. Now the different type of statements and the code generated for the 3 address code. First is assignment statement. We can have a statement like x is equals to y operand z. So operation will be performed on y and z and answer will be assigned to x. Or OP can be the unary operand. So we will be having a statement like x is equals to OPZ. So operation will be performed on z and answer will be saved in x. Next is a copy statement. So we'll be having x equals to y. So value of the right hand side will be copied in the left hand side. Now next is the unconditional jump. So we'll be having go to L. So L is some label where we have to transfer the control. Next is conditional jump. So if X, reloop Y, go to L. Here reloop is relational operator. So we are performing some operation on X and Y, and depending on the answer, we have to jump to label L. Now you can see that in assignment statement we are using here X, Y and Z. So 3 addresses. In the next we are using only X and Z. So 2 addresses. In copy statement, we are using only X and Y, so 2 addresses. In conditional jump, we are having only one label, so only one address we are using. And in conditional jump, we are using X, Y, and L. So 3 addresses we are using. So you can see that anyhow we are not exceeding more than 3 addresses. Now the next type of statement is index assignment. So we may have x of I is equals to y or x is equals to y of I. Again here we are using x, I and y. So total 3 addresses we are using. The next is address and pointer assignment. So we are going for x is equals to address of y or x is equals to pointer y. Now in both that cases we are just using x and y. So 2 addresses we are using. And we can also have the pointer x is equals to y. Now next is procedure call and return. So we may have a call like call p n. So here p is one address, means the address of the procedure which we want to call. This n is a second address, which is the list of the parameter which we are passing as an argument, and y, which is the third address, which is the return value from your procedure. Now the implementation of this 3 address code, it can be done using 3 different way. First is quadruple, then triple and indirect triples. Starting with the first, that is quadruples. Now quadruples here, quad means 4. So it is having 4 field. First is operand, then argument 1, then argument 2, then result. So if we have this kind of 3 address code, for the first statement, let's say at index number 0, your operand is minus. So that is written in your operand field. Then this minus is performed on C. So C is your first argument. There is no second argument as this minus is the unary operand over here, and the answer you are saving in T1. So T1 is your result, right? Now for the next statement, our operand is multiplication, then argument 1 is B, argument 2 is T1, and the answer is saved in T2. Next will be again minus is our operand, argument 1 is C, there is no argument 2, and result is available in T3. And likewise, the code will be generated in the quadruple for this 3 address code. Now next is the triples. Now triple tree means 3. So this table is having only 3 fields, that is operator, argument 1 and argument 2. Now it avoids to enter the temporary in the table and refer the position of those temporaries using the indices. Now for the same code, at index 0 minus c is the operand and the argument 1, but here we are not saving t1 as a result, but wherever we wants to refer a t1, we actually referring the index 0. So in the next statement you can see that my operator is multiplication, argument 1 is b, but in argument 2 instead of t1 we are using the index 0 where the answer of t1 is available, right? So likewise the triple will be generated for the 3 address code which we have written. Now next is indirect triple. Now it is listing the pointers to triples rather than listing triple themselves. So this is the triples, and let's say for suppose the indices of that triples are 14 to 19. Now in indirect triple, at some indices it will just maintain the indices of this triple which you have generated. So this is indirect way, that's why it is called indirect triple. That's all about the intermediate representation. Thank you.